5 seconds. Jawaharlal Nehru expressed in remarkably clear terms the basic difference between the approach of science and the manner in which society likes to function. He said, "What ultimately does science represent? I suppose the active principle of science in discovery. And what is the active principle of any social framework of society? Normally, it is conservatism of remaining where we are, of not changing, of just carrying on. Thus, we come up against a certain inherent conflict between that principle of society, which is one of continuity and conservatism, and that principle of science, which is one of discovery, which brings about change and challenges that continuity. The result is that the scientific worker, although he is praised and patted on the back, nevertheless is not wholly approved of. He comes and upsets things as they are, and we see that, normally speaking, science seldom has the facilities that it deserves except when misfortune comes to a country in shape of war or the like. The growth and development of science and its successful application for human welfare take place only in an appropriate environment, and thus demand changes in the structure of society so that it increasingly becomes less conservative and more flexible. The social transformation from a rigid traditional structure to newer, more flexible forms, the growth of the scientific culture and its application for producing economic change should, in an ideal situation, follow almost parallel, closely behind one another. In real life, social changes are quite difficult to effect. It is much easier to plant a modern scientific culture in what appears to be for it a wrong environment. This is done because of the strong interaction that exists today between science, technology, production activities, and provision of services, and the knowledge that modern science and technology make these operations highly profitable and are forces for economic change. The existence of this scientific culture and the economic changes that it has led to, one hopes, will enable it to also act as a force for social change. The latter will take place only if there are equally significant efforts at other points, place only, such as the transformation Gandhiji tried to introduce in the Indian situation. In these two lectures, I hope to explore them, and in order to ensure that I convey my thoughts to you not merely as an ideological or philosophical discourse, let us first consider the manner in which science, technology, and society are inextricably tied together today in a highly complex manner. To bring this out, I would like to give you 3 examples of development that have taken place in areas that I know and have worked in and with which I have some familiarity, namely physics. The electron was discovered today, the end of the last century. Within a decade, the first electronic value, the triode, was invented. In another 4 decades, immediately after the Second World War, the solid state device known as the transistor was invented, giving rise to the birth of solid state electronics, which has today reached a stage when several thousand devices making up an electronic circuit can be incorporated in one tiny chip of silicon, and it is these developments that have made possible modern computers and space programs, to cite only two examples. Thus, within 3/4 of a century from the discovery of the electron, the field of electronics has grown in an explosive fashion to permeate human life in a multitude of ways in the form of radio and television, public address systems, telephones and communication equipment, radars and defense equipment, in computers and controls, in industry and medicine, and in a whole variety of ways. Let us consider as a second example the area of nuclear science. It was about 6 decades ago that the nucleus of the atom was discovered, and 3 decades later that the phenomenon of nuclear fission was observed. Within a few years of the discovery of nuclear fission, atom bomb based on this discovery wiped out the cities of Hiroshima and Nagasaki. Today there are in the form of nuclear bombs that they are totally from the face of the earth if use were to be made of them. But on the positive side, stemming from the same basic discoveries, there is increasing production of electric power through nuclear reactors and the use of radioisotopes in medicine, agriculture, industry, and so on. Those working in the areas of nuclear and plasma physics might here present humanity with the gift of limitless value by taming fusel reactions. These are the reactions which provide the energy in the sun and in the stars, and which has already been seen in destructive form on earth as hydrogen bombs. If the fusion reactions can indeed be controlled, humanity will have an limitless amount of energy available to it from water, which is so abundant. This has helped us substantially in the development of nuclear science. Here,
subscribe now and press the bell icon. Never miss an update.